Hey all, this is a continuation of Module 1.3. We're talking about transforming graphs. I wanted to take a little bit of time to talk about writing an equation when we don't have a graph. So we've been using a graph to write an equation. We have also talked about looking at an equation and using words to describe the transformation. Now we're going to be given the transformation and we're going to have to write the equation that shows that correctly. Well, let's look at this first one here. I have a parent graph of x squared. Then I'm going to do all this stuff to it, and I need to write the new function, okay? One of the things that we talked about is that the letters name the function. So when I have an f of x function, that means that my function is named Frank. When I transform Frank, he becomes a new function that has to have a new name. You can call that function whatever you want. Most of the time we use the letter G. So he goes from Frank to George. I'm going to write a G function here to describe what's happening to Frank, which is x squared, as he does all of these transformations and becomes a totally new dude, okay? So first of all, I am shifting 2 units left, and then I am shifting 3 units up. So remember that left and right goes inside of parentheses with the variable, and up or down goes outside of parentheses. So I'm going to start with my x, and I'm going to put some parentheses around it so that I can include that 2 units left. Remember that left and right are the opposite. So left is actually going to be a plus 2 instead of a minus 2, kind of like what we would think it would be. This is a plus 2. Notice I've put it inside the parentheses because I'm moving left. The 3 units up is going to be added at the end outside of the parentheses to show that I've moved that Frank function 3 units up. I've got my new function here, g of x equals x plus 2 squared plus 3. I've done all of the transformations and I have got my equation complete. Looking at this next one, this time I'm starting with a parent graph of 4 to the x. I'm shifting it 3 units right and 1 unit down. So I'm going to start by naming my new function. I'm going to call this g of x. And I'm going to keep the 4 to the x the same, right? That doesn't change from the parent function. I'm just going to tack on the 3 and the 1 in their appropriate positions. 3 units right means that I am going to subtract 3 within the exponent. So I'm going to have x minus 3. Notice I tried to write that small so you can see that it's in an exponent because the 1 unit down means that I'm going to add a minus 1 at the end there. Okay? Make sure that you or your teacher can very clearly see which number you've put into the exponent and which one you've put into the regular function so that we know whether you're moving right or left or up or down. I'm looking at this new one here. I've got a parent graph that is an absolute value. I'm shifting 1 unit left. This time I'm going to stretch vertically by 2 units. Remember that a shrink or a stretch has a multiplier in front of the brackets for this one. So let's start with my new function, g of x. And I'm going to put that vertical stretch in front. So I'm going to have a multiplier of 2 in front of the brackets. Now I left myself some space because that 1 unit left is going to go inside the brackets with the x. And remember that left is always plus, so I'm going to write x plus 1. Notice I don't have anything behind here because I'm not moving my function up or down. I don't have anything at the end. Left or right I have in the brackets, and then my multiplier is my vertical stretch. So you can kind of see that different things go in different places, depending on whether it's left or right, up or down, shrink or stretch, or even a flip. Let's try another one here. We've got a parent graph of x squared, and this time we're going to shrink it vertically by 3, and we're going to flip it. Notice I'm not moving it left or right. I'm not moving it up or down. So this g of x is not going to have any plus 2s or minus 5s or anything like that, but I am going to have a multiplier of 1/3. Notice I'm shrinking it vertically by 3, which means that it's 1/3 the height that it was before. Still have that x squared. Now, where does the flip come in? How do I make this function flip? I simply put a negative in front of it. Negative 1/3 x squared means that I've taken that parent function of x squared, I have shrunk it by 3, and I have flipped it, which is why I have the negative 1/3 in front. Hopefully you're kind of understanding how this all works together. If you watch all of the videos together, it kind of makes a little more sense. We're talking about writing a rule from a graph, which is very similar to what we're doing here, writing an equation from words. We can also write the words that describe an equation. And they all kind of go hand in hand and work really well together to help you see how a graph is transforming. As always, if you have any questions, let us know. Shoot us an email or stop by and chat. We're more than happy to help you however we can and have fun transforming your equations.